Hi, I'm Mike Book. Young Living members know many of the rigorous and thorough processes behind our seed to seal promise. They may not know, however, that not only do we have methods in place to maintain ideal growing conditions or optimum distillation, but we also test our oils for purity all the way down to the molecular level. In science, no one test is definitive. It is always better to use multiple tests to confirm results. This is more work, but we are dedicated to this comprehensive testing process to validate our seed to seal commitment. One instrument we use to test purity is the isotope ratio mass spectrometer, or IRMS. In fact, Young Living is the only essential oil company to have this instrument in-house. The IRMS test ensures that the material we are analyzing is actually distilled from a plant. We do this by measuring the isotope ratios of specific atoms in a sample. Atoms of the same element can have different masses. These are called isotopes. For example, carbon can have a mass of 12 or 13, depending on the number of neutrons in its nucleus. Living plants take up specific ratios of these isotopes from the atmosphere during photosynthesis. Specifically, plants get carbon from carbon dioxide in the atmosphere and hydrogen from water. The IRMS allows us to measure the isotope ratios in essential oils to see if they match the ratios that should be found in the living plants. IRMS is a very sophisticated testing method. All atoms have isotopes, but we typically focus on carbon and hydrogen because they are atoms associated with living plants. If the carbon and hydrogen ratios don't correlate to the expected ratios found in the original plant, then we assume the product must contain a synthetic. This would trigger further analyses using other instruments in our lab. Carbon is significant because it indicates that the samples we're testing come from plant material and not something synthetic. I'm actually reviewing some IRMS data right now for some wintergreen oil, and the ratio of carbon-13 to carbon-12 isotopes indicates that the sample has gone through photosynthesis and is therefore a naturally occurring substance. If synthetics were present, there would be a different ratio of carbon isotopes, indicating a lack of purity. This technique is very complex and requires extensive training, but it's just another way we use state-of-the-art science to help ensure our seed to seal promise.